Q9793. Upon landing, spoilers. A. Decreased directional stability on the landing rollout. B. Function by increasing tire-to-ground friction. C. Should be extended after the thrust reversers have been deployed. The correct answer is B. Spoilers, also known as speed brakes or ground spoilers, are deployed on the wings of an aircraft during landing to assist in reducing the lift generated by the wings. When activated, the spoilers disrupt the smooth airflow over the wings, creating additional drag. This increased drag helps to slow down the aircraft and increase the tire-to-ground friction, which aids in decelerating the aircraft during the landing rollout. Spoilers are typically extended after touchdown to assist in braking and to improve the effectiveness of the wheel brakes. 9793-2. Ground spoilers used after landing are: A. More effective at low speed. B. Equally effective at any speed. C. More effective at high speed. The correct answer is C. Any object has an effective shape that is typically slightly different from its physical shape thanks to the boundary layer. Additionally, the boundary layer may split off from the body, giving rise to an effective shape that differs greatly from the actual shape of the object. Lift and drag are dramatically reduced as a result of the boundary layer's altered physical form. This indicates that the airfoil has stalled. Q8341. Which is a purpose of wing-mounted vortex generators. A. Delays the onset of drag divergence at high speeds and aids in maintaining aileron effectiveness at high speeds. B. Increase the onset of drag divergence and aid in aileron effectiveness at low speeds. C. Breaks the airflow over the wing so the stall will progress from the root out to the tip of the wing. The correct answer is A. Wing-mounted vortex generators are small devices that are installed on the wing surface. They are designed to manipulate the airflow over the wing and improve its aerodynamic performance. One of the main purposes of wing-mounted vortex generators is to delay the onset of drag divergence at high speeds. At high speeds, airflow over the wing can become turbulent and separate from the surface, leading to increased drag and reduced lift. Vortex generators create vortices or swirling flows in the boundary layer of the wing, which helps to energize the airflow and delay the separation of the boundary layer. This delays the onset of drag divergence, allowing the wing to maintain higher lift and lower drag at higher speeds. Additionally, wing-mounted vortex generators can aid in maintaining aileron effectiveness at high speeds. As the airflow becomes more turbulent and separated at high speeds, the ailerons, which are control surfaces on the trailing edge of the wing, may become less effective in controlling the aircraft's roll. By using vortex generators, the airflow over the ailerons can be better controlled and maintained, ensuring their effectiveness in high-speed flight. Q8330. What is the purpose of a servo tab? A. Move the flight controls in the event of manual reversion. B. Reduce control forces by deflecting in the proper direction to move a primary flight control. C. Prevent a control surface from moving to a full deflection position due to aerodynamics forces. The correct answer is B. A servo tab is a small auxiliary control surface attached to a primary flight control surface, such as an aileron or elevator. Its primary function is to assist in moving the main control surface by deflecting in the opposite direction. When the pilot initiates a control input, the servo tab deflects, creating an aerodynamic force that helps move the main control surface in the desired direction. This reduces the control forces required by the pilot, making it easier to maneuver the aircraft. Q8338. Which direction from the primary control surface does a servo tab move? A. Same direction. B. Opposite direction. C. Remains fixed for all positions. The correct answer is B. A servo tab is designed to move in the opposite direction of the primary control surface to assist in its movement. When the pilot initiates a control input, the servo tab deflects in the opposite direction, creating an aerodynamic force that helps move the primary control surface. This arrangement reduces the control forces required by the pilot and improves the maneuverability of the aircraft.